Hi guys, today we are going to learn about capillary electrophoresis. So what is capillary electrophoresis? Capillary electrophoresis is defined as a separation technique in which charged species are separated based on charge and size by their different rates of migration in an electric field. This is the schematic diagram of capillary electrophoresis. This diagram shows the cross-section of fused silica capillary. Typically, the capillary we use in CE has an inner diameter between 10 to 100 micrometer with length of about 40 to 100 centimeter. Theory of capillary electrophoresis. The sample is injected into a buffered solution retained within the capillary tube. When an electric field is applied to the capillary tube, the sample's components migrate as a result of two types of mobility. Types of mobility. First is electrophoretic mobility. It is a measure of solid mobility to move through the conductive medium in response to an applied electric field.
When the voltage is applied across the capillary, the cations will be attracted to the negatively charged cathode. The anions will be attracted to the positively charged anode, while the poor neutral species remain stationary. Since neutral species are not charged, they won't be affected by the applied electric field. And there are two major factors that affect the electrophoretic mobility of a charged analyte. First of all, the electrophoretic mobility is directly proportional to the ionic charge on the analytes. So if the analytes are of the same size, the cations that are more highly charged will move faster towards the negatively charged cathode, while the anions that are more highly charged will migrate faster towards the positively charged anode. Secondly, the electrophoretic mobility is inversely proportional to the frictional retarding force of the analyte. If the analytes are of the same charge, the bulkier cation will experience a stronger frictional retarding force, therefore moving slower towards the negatively charged cathode. Similarly, the larger anions will move slower towards the positively charged anode. In addition, the frictional retarding force of an analyte not only depends on the size, but also the shapes of the analytes, as well as the viscosity of the medium. The more viscous the medium is, the slower the electrophoretic mobility.
Second is electroosmotic flow ability. It is the movement of conductive medium through the capillary in response to an applied electric field.
Because of the deprotonation of the selenol groups on the silica surface, the capillary surface is basically negatively charged. The negatively charged surface will attract the positively charged cations from the buffer solution, forming a layer of tightly absorbed cations, which is called the fixed layer on the silica surface. However, the tightly absorbed cations can only partially neutralize the negative charge on the capillary surface. Therefore, the negatively charged surface can still attract more cations from the buffer solution. This forms a diffuse layer, where the concentration of cations is higher than the concentration of anions. Together with the fixed layer, these two layers are called the electrical double layer. At the center of the capillary tube is the bulk solution, where the concentration of the cations and anions are about the same. To complete the cross-section of a capillary, we have the diffuse layer and the fixed layer at the other end too. Let's take a closer look at what will happen when we apply a voltage across the capillary. On one end, we have the anode, which is positively charged. On the other end, we have the cathode, which is negatively charged. When the voltage is applied across the capillary, the cations in the diffuse layer will be attracted to the negatively charged cathode, dragging the bulk solutions along with them. This is what we call the electroosmotic flow.
Capillary electroseparation methods. Capillary electrochromatography. It is a form of capillary electrophoresis in which a stationary phase is included with the capillary column. Capillary zone electrophoresis. It is a form of capillary electrophoresis in which separations are based on differences in solutes' electrophoretic mobilities. Next is micellar electrokinetic capillary chromatography. It is a form of capillary electrophoresis in which neutral solutes are separated based on their ability to partition into a charged micelle. Next is under steady-state process, which is capillary isoelectric focusing. It is a technique used to separate peptides and proteins. These molecules are called Zwitter ionic compounds because they contain both positive and negative charge. This is a closer look on CIEF. Capillary isotarcarphoresis, CITP, the only method to be used in a discontinuous system. The analyte migrates in consecutive zones, and each zone length can be measured to find the quantity of sample present. Advantages of capillary electrophoresis. First is fast separation. Second is good peak resolution. Next is small sample volume needed. And lastly, can be detected quantitatively by using suitable detector. Application of capillary electrophoresis. First, DNA fingerprinting. Amplified DNA can be separated. Separation can be at a resolution of one base pair, and individual nucleotides can be identified, so allowing a high-resolution map of the DNA to be created. Drug analysis. Used in pharma for the analysis of drugs and provide a good resolution to separation. When separating certain compounds like amine, CE can use a non-reactive capillary surface at a certain pH to provide good separation. Characterization of protein. Used to separate amphoteric molecules such as protein, thus allowing protein identification. Molecules are separated by allowing them to migrate to their isoelectric points before mobilizing all the molecules past the detector. Ink analysis. MECC has been developed and applied to the analysis of inks extracted from paper, suitable for evaluating the origin of document based on the chemical composition of inks due to its high resolving power relative to inks. That's all for now. Thanks for watching.